Our goal is to assemble a parabola based on aluminum and cardboard, then heat a water container with the help of the refraction and the angles of the parabola. Get it to warm up enough so that when there is contact, you can tell the difference. Then check with the use of the topic of the parabola that we use the exact measurements as they should be so that the water warms up.
By making our heater from an umbrella, we have as an initial data the values of the measurements of the height and the width, in other words, x and y parting from our vertex. All we needed then was the measurement of p, which will determine the position of the focus. We position our vertex in the origin, so the formula was x squared equals 4py. The next step was to replace the values we already had, x as 33 and y as 30. Then, we put all the known values on one side of the equation in order to get 4p equals 33 squared divided by 30, simplified as 4p equals 36.3. Then, we pass the 4 to the other side of the equation just to leave the unknown value on the left side. After making the corresponding operation, we got that p equals 9.075 centimeters. Therefore, if p is the distance from the vertex to the focus, our focus will be 9.075 centimeters above the origin.
A hyperbola is a set of all points x, y, such that the difference of the distances between x, y and the two distinct points is a constant. The fixed points are called the foci of the hyperbola. Asymptotes are imaginary lines that are never touched by the curves of the graph. Each hyperbola has two asymptotes that intersect at the center of the hyperbola. The asymptotes pass through the corners of a rectangle of dimensions 2a by 2b, which is referred as to the fundamental rectangle. A hyperbola contains two vertices that lie on an axis of symmetry that is called the transverse axis, which is either horizontal or vertical. The midpoint of the transverse axis is called the center of the hyperbola. A, B, and C are related to the transverse axis, conjugate axis, and focal length, respectively. A is the distance from the center to each vertex of the hyperbola. B helps us to complete the fundamental rectangle, and C gives the distance from the center to the foci. A parabola is the set of points in the plane that are equidistant from a fixed line called the directrix and a fixed point called focus. The midpoint between the focus and the directrix is called vertex, located at h, k, and the line passing through the focus and the vertex perpendicular to the directrix is called the axis of symmetry of the parabola. The latus rectum of a parabola is the chord that passes through the focus and that is parallel to the directrix.
A circumference is a set of points that are equidistant to a fixed point called center. The distant mean is radius. A section inside the circumference is called a circle. A segment of the circumference is called an arc or sphere. An ellipse is the set of points where the sum of the distance from two distinct fixed points focus is constant. The line that passes through the foci intersects the ellipse at the vertices. The chord joining both vertices is called the major axis, and the midpoint is called the center. The chord perpendicular to the major axis is called the minor axis. The end point of the minor axis are referred as covertices.
First, we cut the umbrella. Then, we cover it with aluminum. Then, we put it in the sun and generate the heat. Concentrate the sunlight in only one point. Then we put a thermometer to measure the temperature. Then we leave it like that for a while and wait till the water was hot. And then we checked it and checked the thermometer to see if the water was already hot or boiling. But no, the water wasn't boiling. This was very hot. We put the water in a small glass recipient to the side of the stick. Thanks to the design of the umbrella, it doesn't let us to put it in the center, but the water was hot still. And the experiment was successful.
Initially, we placed the water in a glass container from which we took the initial temperature of 18 degrees Celsius After waiting about an hour and a half, we returned to check the temperature of the water, which rose to 36 degrees Celsius. This means that the experiment worked. A higher temperature was expected and it was successful. Thanks to this, we can say that the position and materials of the solar heater were effective.
Get out of control.
In conclusion, we saw that our panel did hit the water thanks to the exact measurements and angles because they are needed for everything to work.
Since our heater is a parabola, it must have a specific point where the solar light is forced to pass through a certain point, the foci, where it heated our water. We did accomplish our goal since the heater works very well, thanks to our calculus previously explained, obtaining positive reactions due to the hard work of